This right here is Ceres. For some of you, this might be your first visit to this beautiful dwarf planet, but for some of you, maybe it is not. What is Ceres? Well, Ceres is technically a dwarf planet, but it's also, or it can also be classified as an asteroid because it is located in our asteroid field, which is between Mars and Jupiter. Now today, instead of talking about planets and instead of talking about stars, we are actually going to talk about the asteroid belt that is in our solar system, and that is also very important to our planet and to our solar system as well. And specifically, I actually wanted to talk about what is in this asteroid field, what would happen if we actually combine all of these rocks into one, and also talk a little bit about the history of the belt as well. Welcome to What the Math. Now, first of all, let's actually explore 4 of these most massive so-called asteroids in this asteroid belt, starting with Ceres. So this is the surface of Ceres, and you can kind of see that it's a relatively bright dwarf planet. And this is actually the only dwarf planet in the asteroid belt. And the only reason it's a dwarf planet is because if you were to move away from it, you would notice that it's actually spherical. It's the only object in the asteroid belt that is spherical because of its mass. Its mass is large enough for it to create the spherical shape, but the other objects are not spherical. So the second biggest object is called Vesta, and you'll notice that Vesta is basically not a sphere anymore. So this is actually considered to be an asteroid, even though its size is actually just a little bit smaller than Ceres. And here the size this is actually 570 kilometers in diameter. This is larger than most states in the US, and it's basically the size of a medium-sized country on our planet. So this is a very large asteroid. And its surface, just like Ceres, has a very similar feature. If I actually try to land here, you'll notice that Space Engine will actually procedurally generate a surface for me, so it does look pretty cool. So this is the second asteroid and the second biggest one in the asteroid belt. And what you see here, this is actually ice deposits, which make this this particular asteroid a little bit brighter than usual. And the third asteroid here is called Pallas, and this is actually, it's not as spherical as it is in this particular game. It's actually a little bit less spherical than that, but it does look pretty cool as well. And the size of this particular asteroid is very similar to Vesta. It's about 500-ish kilometers in diameter, and the surface also looks very similar to the surface of both Ceres and Vesta. Now the thing about Pallas is that we've actually never been to this particular asteroid, so we don't really know what it looks like, but we have visited both Ceres and Vesta. As a matter of fact, there is still a spacecraft that is currently taking pictures of Ceres, and here's actually a really awesome video that motivated and inspired me to create this video, because very recently, for me only a few days ago, on February 1st of 2016, NASA has released this compilation of amazing photos of Ceres, and they've actually released it for everyone to see, and they made a movie out of it, and it's absolutely beautiful. Now they have these pictures for both Vesta and Ceres, but unfortunately not for the other asteroids like Pallas. We don't really know what it looks like. We haven't been here ever, but maybe one day we'll get to visit it as well. And the fourth asteroid, called Hygiea, is also very important. It's actually, once again, not as large in real life as it is here, but it is as bright as this because it does have a lot of ice on it. This is actually a very icy asteroid, and so it's very reflective, very bright. You would very likely have to squint while looking at it. If you'll try to land on the surface here, you'll notice how much brighter it is. And so once again, we haven't really been to this one either, and so all we know about it is that it's very large, it's quite massive, but obviously not as big as Ceres, because Ceres is the biggest one in this region. And so what we're going to do now is we're going to switch to Universe Sandbox 2 and take a look at the asteroid in a little bit more detail, and then try to combine these objects into one very large, I guess it would be a planet, because to be a planet you have to be the only object that is massive enough and spherical enough to be in a certain orbit. And we'll see what it looks like and compare it to existing planets as well. And so in Universe Sandbox 2, if you actually choose this right here, solar systems, non-moons over 200 kilometers, you'll have a solar system that has a lot of stuff going on here, but we're particularly interested in this region right between Jupiter and Mars, where, well, there's actually supposed to be quite a lot of asteroids in this area, but we're more interested in the 4 main ones. So there's Vesta right here. Its size is more realistic here at something like 265 kilometers in radius, and this is what it looks like here. It's a little bit too spherical still. It shouldn't really be that spherical. But nevertheless, this is what it is. Hygiea is at about 204 kilometers radius. Then we have Ceres, which is the biggest one here at 476, and this is actually a very... Ooh, too fast. This is a very realistic image of what Ceres looks like. This is actually an almost identical view to what our probe on Ceres currently is looking at, except that colors here have been a little bit exaggerated. It's not actually so blue, it's not actually so red. It's a little bit more mellow than that. And lastly, the last one here is, of course, Pallas, and Pallas is right here. And since we don't really know what it looks like, it's just a brown blob of stuff. And so, yes, there's 4 asteroids, and we obviously also have a variety of rocks in this area, and we can include that or add that by going into, and right here under rings, if you choose Saturn, go down a little bit and choose shape of Taurus and a distance of, let's just say, approximately anywhere between 2.6 astronomical units to something like 2.8 astronomical units, and then you just add the ring, and there you go. So there's our first ring. It's actually a lot larger than this. It's more likely to look like this, and has a lot more rocks in it as well. We currently have discovered something like 700,000 or 800,000 of these individual rocks. Most of them are not particularly large. They're anywhere between 10 kilometers, or sorry, anywhere between a really small size and to about 10 kilometers. But the majority of them are basically tiny particles. There's actually quite a lot of dust here as well. And unlike a very common misconception, if you were to actually go in here, if you were to fly in between them, you would not even possibly see one. They're actually really far away from each other. If you play modern video games, or if you watch movies like Star Wars, we often told that, you know, asteroid belts, they're very dense, there's a lot of asteroids, it's very sort of difficult to fly between those asteroids, but that's not true at all, because if that was true, those asteroid belts would not survive for very long. So the reality is that if you were to actually fly through the belt, let's just say you're going from the sun to another planet, and we've done this several times. As a matter of fact, there's at least 12 different spacecrafts that have done this. They flew through the asteroid belt, and the majority of those spacecraft have not seen anything. They obviously did not collide with anything, but they were so far away from objects in that region that they did not even see them. But the thing is, since these other rocks are very small, the majority of the mass of the asteroid belt is actually in these 4 objects. Ceres is about 1/3 of the entire mass of the belt, and then Vesta, Hygiea, and Pallas, altogether, all 4 of these, they add up to about half of the mass. So basically, if we were to take each 4 of these objects and then multiply them by 2, we would essentially get the entire mass of the asteroid belt. And this is what we're going to do a little bit later on, where we're going to try to combine them into one. Now, if you actually want to learn a little bit more about Ceres and Vesta, or if you actually want to see me terraform Ceres, there's a video I made a few months ago where I did just that, and I talked about the history of Ceres, I talked about its features, and its finding as well. This is an object that we've known about for over 200 years. It's been discovered a long time ago, and so this is actually one of the more original discoveries in astronomy. But anyway, so let's talk a little bit more about the asteroids. So there's actually 3 main types of asteroids, and here's a picture showing you these 3 types. So there's something called carbonaceous or carbon-based asteroids. These are a little bit lighter usually, and they basically contain a lot of carbon stuff on them. So including things like carbon dioxide, obviously, but anything with carbon, they have it on their surface and inside. There's also something called S-type or rocky type, silicon type asteroids. These are a little bit darker, a little bit less common, and basically they're the rocky asteroids. And the last type is the M or metal type. These are more rare, a little bit darker, and these are the more heavier, more dense asteroids that obviously have various metals on them, including some really cool metals like things like platinum and gold. And this particular belt has actually changed quite a lot since the creation of the solar system. As a matter of fact, originally, the scientists have estimated that this belt had so much material that you could actually make a new planet Earth from it. So the estimate is that it had as much mass as the entire Earth. Now, however, the mass is much smaller. Now, if you were to combine everything, now let's actually do that right now. We're gonna go into a new simulation and do that from scratch. you'll notice how small the mass is. So let's actually find out how small it is. So we're going to add, let's actually start with Ceres. We're going to put Ceres here. So Ceres goes in the middle because that's the biggest one. And then we're going to, well, first of all, let's decelerate time a little bit. We're going to start with the second biggest, which is, of course, Vesta. And it's not here on the list for some reason, but here it is. So we're going to put Vesta, and we're just going to do this. We're going to just randomly place it still, and it's going to slowly approach Ceres by itself. Then we're also going to put Hygiea. Hygiea is going to be the next. Oh, here we go. Here's the collision. Beautiful collision coming up. Look at that. So gorgeous. Oh, this is beautiful. Every time something collides in the Universe Sandbox 2, it's just amazing. So this was 2 of them. Now let's put Hygiea in here as well. And Pallas. Pallas is the last one. So we're going to do this 2 times though, because like I said before, the total mass of the asteroid belt is twice the size of all of this. So here comes another Pallas and another Hygiea. And finally another Vesta. So this is a very approximate estimate for if how big the entire asteroid belt would be if you were to combine all of the rocks together. So not including the fragments, but they're so insignificant in size that we can ignore them for now. And the total mass here is, well, I don't know if you can see this, but it's about 2.12 times 10 to the power of 21 kilograms. The total size of this object is slowly increasing. It's not going to go very far, but we're going to wait a little bit to see how big it gets. But just to show you, and I'm going to just remove this for a second. Here you go. It's actually smaller than Pluto. It's smaller. It's much smaller than Pluto. The entire Pluto is much bigger. As a matter of fact, twice as big and twice as massive as all of the asteroids in their inner asteroid belt. And look how beautiful this has become. So it's pretty awesome. But you can still kind of tell some of the features of Ceres on the surface apart. This actually is a little bit more similar to Pluto's moon called Charon, or Charon, if you want to be more proper in pronunciation. And Charon or Charon is not here for some reason. Oh, I thought it was here. Maybe it's not. Maybe it's been not added or removed. I'm not sure where it is. But anyway, so yes, there is a moon that Pluto has, and it's actually quite similar in size to this particular creation that we have. This is going to be, we should rename this. Let's rename this the Asteroid Belt, because there's no better name for it. And if you want to compare it to things like our moon, this is about 4% the mass of our moon. And if I were to actually show it to you here, this is our moon. So our moon is huge in comparison. This is how big our moon is. Earth is obviously much bigger. If I were to, Earth would be in planets. Earth is this big. So see how tiny and insignificant all of the asteroids are in comparison to Earth, which also, makes you think if they all collided with Earth at some point, I think our planet would still be fine. Even if they all came together. No, okay, if they all came together at the same time, maybe it would be in trouble. But if they came one by one, I think it would be fine. We'd probably have a few extinctions here and there, which is, I guess, sounds scary, but our planet would eventually survive and overcome all of these difficult challenges. I just realized maybe Charon is actually here. There it is. Okay, it's under moons. I made a mistake. It's under moons. So see how it's actually about the same size as Pluto's moon called Charon? It's about the same size. It's also the same mass. Now, I did kind of mention that originally the actual asteroid belt was much more massive, and what happened to it is that because Jupiter was so close to it, and let me just for comparison show you how what Jupiter looks like here. Because Jupiter was so close, its gravitational field actually disrupted a lot of these so-called planetoids that were supposed to create a new planet, and it sent them away into the outer solar system, or possibly even into inner solar system, caused some of them to collide with other planets, and many of them have actually just disappeared and never returned. Or maybe they did return, maybe they caused collisions with our planet, or maybe some of them even have become satellites or moons of other planets. For example, we don't really know where Triton came from. The Neptune's moon Triton has a very unusual orbit, and I've showed that to you in one of the previous videos, and it's definitely a moon that has been captured from somewhere. So we don't really know where it came from. Maybe it came from this region, from the region of asteroid belts. So are you ready for Jupiter? This is Jupiter. Look at how massive it is. Jupiter in comparison to the entire asteroid belt. It's just a tiny rock in comparison. And this is why this huge object disrupted the original asteroid belt and did not allow for this planet to basically to be born, to create itself. And if you actually want to see how the planets are made, I did make a video about creating planets from protoplanets. In some of the previous videos, I actually detailed how it's done. And this is essentially what would have happened here as well. So this would eventually become a planet. So if I keep adding, I'll just add more Ceres. Or is that Ceres? What's the plural of Ceres? I think it would be Ceres. And this is an original Ceres. It's actually not much smaller. So we're just gonna keep adding these like over and over. So this is what it would be like if there was actually more planetoids, more dwarf planets in the asteroid belt still. If they were still there, if they were still kind of orbiting each other, they would eventually, all of them, combine into an actual very large or possibly quite massive planet, possibly even larger than Earth. We don't really know how big it would have been, but it would have been pretty big and pretty massive. And we don't really have a name for it, but it would be nice to have a hypothetical name. I guess for now we can just call it Mega Ceres, very, very large Ceres, because that's what it's going to be. Now I actually have lost count to how many of these I've added already, but I think it's about 100. There's about 100 of Cereses. And here they come. They're all going to be combining into one mega large planet. We're going to try to terraform this as well, just for fun. All right, so that looks pretty nice. All right, so what I did actually mention is that there is actually water on Ceres, which is why I said terraform. And this is not a very realistic image. There's definitely more iron in here. There's definitely a little bit of water, actually quite a lot of water. And as a matter of fact, Ceres has quite a large amount of water. In 2014, we officially discovered water deposits on the surface and also in underneath Ceres, which means, it gives us a good idea for what the asteroids contain. So both comets and asteroids actually have quite a lot of water, both on the inside and also on the outside as well. Alright, so while we're actually terraforming this, let's just finish talking about the asteroids. So the interesting thing about asteroid belt is that the actual collisions between asteroids, between very large asteroids, don't occur very often. As a matter of fact, there's only like one collision between medium and small size asteroids that are about 10 kilometers in size, something like every 10 million years. That's actually a very long time when you think about it. So in your lifetime, there hasn't been a single asteroid collision in the asteroid belt, which is actually makes you think about it, right? It is called an asteroid belt, but it's not as diverse, it's not as populated as many people think. So we're gonna cool this planet down now. Name this Mega Ceres. Oh, look at this beauty. And now we're gonna try to put some water, liquid water in it, and give it some interesting and dynamic surface if we can. The other thing about the asteroid belt is that out of all of the meteorites we found on our planet, as a matter of fact, we found something like 50,000 different meteorites over the many years that we started looking for them. All of the, or not all of them, but about 99.8%, almost all of the asteroids actually came from the asteroid belt. So that's how common the collisions with other planets are. So between each other, they don't collide very much. But with other planets, with other objects, they collide quite a lot. And that's because obviously this is a much more massive object and much bigger target. So it's a lot easier for an asteroid to be attracted by a planet than it is by another asteroid. Alright, so while this is cooling down, we're going to try to accelerate time here and give it a little bit of atmosphere as well. Increase surface pressure to 1 atmosphere. Boom. There we go. Now we're going to have clouds on the surface as well. Oh, and one more thing about asteroid belt is that most of the asteroids, they actually orbit kind of together in something called asteroid families. So they're not really by themselves, they're not really solo. As a matter of fact, there's something like 30 different family of asteroids, and that means that most asteroids, they just kind of chunk together and they fly in these like family formations. And most of these families actually do have names. Some of them have either Latin or Greek names, and most of them have quite a unique and quite a specific orbit, so they don't actually intersect with each other, but the asteroids inside the family can obviously collide with each other a little bit more often than with other parts of the asteroid belt. Alright, so we're almost done here. I'm just going to decrease water a little bit just to give ourselves a little bit more continents, and here we go. This is our mega Ceres, a hypothetical planet that would have been had it not been disturbed by the supermassive Jupiter. Now this is actually a relatively large planet. It's smaller than Earth. It's about 2,000 kilometers in size, 1.1 size of moon or mass of moon, and it has at least two of its own moons, two fragments orbiting around it. And this is actually pretty awesome. I kind of like the look of this. This is really interesting. And I think that's all I wanted to do in this video. I just wanted to talk about the asteroid belt and check out what happens if you combine all of these objects into one. Now, hopefully you enjoyed this video, and if you did, don't forget to subscribe and don't forget to like and share this video with your friends who might like space videos. And there's definitely a lot more space videos coming, so don't forget that if you subscribe, you're going to be notified about those videos right away. And what I would like to ask you is, do you have a really cool name for this hypothetical planet that would have been if Jupiter didn't actually disrupt it? What would you call this planet? How would you name it? Let me know in the comments below, because I'm kind of curious. Anyway, thank you so much for watching. I'll see you in the next video. Game you later, and bye-bye.